This video will help you set up a web server with two important features. The first is a domain name, which will allow you to refer to your server by a conventional, easy-to-remember name that you'll automatically update if and when your server's IP address changes. The other is a certificate, which will allow clients to use HTTP secure, that is HTTPS, to communicate with your web services. As discussed in a prior video, domain names are typically used instead of IP addresses because IP addresses are both hard to remember and are a function of the network, not the server, so they can change over time. The domain name server can be updated to always point to the correct IP address. Another useful function is that a certificate can be issued for a domain name instead of an IP address. This is a feature we'll use later in this video. Second-level domain names must be purchased from an authorized registrar. A .com or .net domain typically costs about $10 a year, but some others may be obtained at little to no cost. One service, freenom.com, would give out free second-level domains with an off-brand top-level domain such as .ga or .tk. It's a little bit of effort, and there's potentially some cost involved, so we'll skip this option for this video, but know that it's possible to get a free domain. The other option, which is slightly less tedious, is to set up a third-level domain with a service. This requires very little effort, and it's what we'll use in this video. Another advantage is that these services often will provide a dynamic DNS service, which allows you to automatically update your IP address whenever it changes on the server. Though this is also possible with a second-level domain, by delegating to the dynamic DNS service, it's less convenient. For this video, we'll be using the dynv6 service at dynv6.com, which is just one of many dynamic DNS services that will issue you a third-level domain off one of several second-level domains. It's very easy to get started. All you need to do is to enter the domain you want, the second-level domain you'll use, and your email address. And so for this video, I'll use example 123456, dynv6.net, and I'll enter my email address. And click Go. If it doesn't say name is available, you'll need to choose a different name because somebody else has chosen that already. Once done, you can see it's successfully registered, but it's not active yet because I need to confirm my email address. I'll do that now. Once you've set up your account on Dynamic DNS, you should be able to sign in. And then you'll be presented with a list of My Zones, including the one that you set up. We'll click on that, and we can see that the IPv4 address is not configured. Now, we could directly enter the IPv4 address of our server in here, but we're going to want to set up DD client, which you can find the instructions for that under the Instructions tab. Now, this will allow you to automatically update the IP address if it ever changes. The next thing I need to do is to log into our server, and then run sudo apt update. This will ensure that the list of packages available will be updated. Next, we'll run sudo apt install dd client. This will pull up a text-based user interface where we can enter the required information. We need to set dyndns2 as the protocol. We need to enter dynv6.com as the server. None is the username. Our password is the one found here. And I'll paste that in. And I'll paste it in again. Next, I will say that I want web-based IP discovery. And lastly, we'll enter our domain 123456.dynv6.net. Once this is done, we're going to need to update the ddclient.conf file. The reason is something we can check out using systemctl. If I run sudo systemctl status ddclient, we can see that ddclient failed at this point. It's running and it's sleeping for 280 seconds right now, and so it's not going to run our update again for 280 seconds. Before that update happens, I'm going to sudo nano /etc/ddclient.conf and fix it so it doesn't fail next time it updates. First thing we need to do is add SSL equal yes at the top of this file. The next thing is we need to remove the quotes around the password. Once that's done, say yes. We may need to remove the backslashes as well, although I don't think that's actually required. We can check this by running sudo ddclient, and it'll probably fail the first time, but it's annoyed at me right now because I didn't wait 5 minutes between last attempts. And so I'm going to try it one more time, and this time it's successfully updated. I could have also waited and it might have fixed itself. But let's verify that things are working properly. We have two places that we can use to verify this. First thing is that I'm going to exit and try to relog in. But instead of using my IP address, I'm going to use example 1234556.dnv6.net. Say yes because it's never logged into this host before. It previously logged into the IP address. And you can see that now we're able to log in, and we were able to log in using our new domain name. The other place that we can check is on dnv6.com, and you should see that the current status has your IP address of your server set already. Now that we have our domain, we can get a certificate and set up HTTPS, or HTTP secure. The idea of HTTPS is that it encrypts all traffic between a web service and a client. It does this using encryption keys. However, how do you exchange the encryption keys securely? The solution invented for this is certificates. Before accepting that data comes from a particular server, you verify its certificate with a trusted certificate provider. In order to get a certificate, the trusted provider ensures that you own the server. This ensures that only this owner of a certificate could have sent the certificate to you, assuming that everything checks out. The other factor is that your browser must have a list of trusted providers, which it comes with, or you have to add new trusted providers to it. Let's Encrypt is one such provider, and it really revolutionized HTTPS on the internet because it's completely free. Other certificate providers cost quite a lot of money. In theory, you may want to use these for various reasons, most likely that you want a long-term certificate. But in practice, Let's Encrypt works phenomenally well for a simple web server. It's also very easy to set up using certbot, a program they provide. It's installed via another package manager called Snap, which is similar to apt and comes pre-installed on Ubuntu Linux. A few commands will get you up and running with HTTPS. The first is sudo snap install core. This will take a second. This is similar to apt update. And now we'll do sudo snap refresh core. Actually, this is more similar to apt update. So no updates available. Sudo snap install -- classic certbot. So this is the certification bot that connects to Let's Encrypt. Now we're going to install certbot for Nginx. So certbot will take care of updating all of the Nginx configuration files for us. We need to enter an email address. And then we want to read the terms of service agreement, but I'm going to say yes here. And do I want to share my email address with EFF? I'll say yes, but you can say no to this. And then lastly, and most importantly, we have to add our domain name we want our certificate issued for. And in this case, I'm going to do example 1234556 at www.dynv6.net and hit enter. It'll request that certificate. In part, it's also verifying ownership, and so Nginx needs to be set up. And now we're done. So we have a few things that we need to do to verify that HTTPS is working. The first is that we probably want to check our browser. So if we go over to our browser, we should now be able to go to example 12345.6.dynv6.net. And we get our welcome page that we set up in a previous video. We can also notice that this is now being served at a secure site. The connection is secure. And so our URL here is actually https:// not HTTP. The other place that we can check is our settings for Nginx. If we go to sudo nano /etc/nginx/sites-enabled/default and scroll down, we see our previous server block, but something changed now. The thing that changed is that a new server block got added specifically for example 12345.6.dynv6.net. This is a service on port 443. As we'll see, it's set up for that. Listen 443. And then down, we'll see that there's a server block for port 80 that redirects to port 443. So it redirects to HTTPS. And so if somebody tries to access our site with an HTTP, it will automatically redirect to HTTPS. You can see that right here, return 301, which is an HTTP redirect to HTTPS. I'll note that if you add a subdomain, which is possible on the dynv6.com website, you'll need to repeat this process for that subdomain. Each subdomain will need a unique certificate. Okay, that's it. In summary, you should now be able to set up a domain name to point to your server's IP address, and it should automatically update even if you shut down your server and get a new IP address. You should also be able to set up HTTPS for a web server at that domain via Let's Encrypt certbot. This is very important because HTTPS is a soft requirement for many devices, especially those from Apple. If you don't use HTTPS, your users may get a warning, which is unsightly and annoying for them.